Assalamualaikum dan salam sejahtera. Nama saya Raja Muhammad Ashraf bin Raja Azlan. Saya daripada kumpulan 4. Hari ini saya akan menerangkan tentang kerja taking off list bagi mini project Construction Cost Estimation. Kami memilih projek iaitu substructure for 2 unit of semi-detached house. Projek ini berdasarkan drawing daripada syarikat perunding iaitu Jurutera Perunding Fajar Sdn Bhd. Yang digunakan bagi revision construction drawing bertarikh 23 Oktober 2018. Untuk projek ini, kami perlu menyediakan taking off list, sort form dan juga bill of quantity. Berdasarkan drawing structure yang diberikan, taking off list ini sangat penting kerana ia digunakan untuk mengira kuantiti kerja sebelum kos pembinaan dapat dianggarkan. Pertama sekali, saya akan terangkan tentang kaitan antara taking off dengan drawing. Semua ukuran dalam taking off diambil terus daripada drawing structure seperti ukuran panjang, lebar, ketebalan slab, side foundation dan juga aras excavation. Sebagai contoh, ukuran ground floor dan rough foundation diambil daripada plan structure untuk mendapatkan keluasan keseluruhan bangunan. Dalam taking off list, kerja dibahagikan kepada beberapa elemen utama iaitu earthwork, rough foundation dan ground floor. Seperti yang dilihat di taking off list form ini, elemen pertama iaitu earthwork. Kerja yang terlibat ialah site clearing, excavation dan disposal. Okey, dan untuk dalam elemen earthwork itu ada site clearing dan excavation, dan untuk excavation kami menggunakan formula panjang darat lebar dalam kedalaman untuk memperolehi jumlah ketebalan hardcore dan juga jumlah konkrit slab iaitu sebanyak 300 mm daripada drawing tersebut. Okey, untuk nilai disposal pula merupakan jumlah tanah yang telah digali daripada excavation tadi. Okey, kita seterusnya ke elemen kedua iaitu rough foundation. Rough foundation kami mengira beberapa komponen seperti concrete, formwork, reinforcement dan proof membrane atau dikenali sebagai DPM, dan akhir sekali hardcore. Okey, untuk formwork kami di dalam drawing ini terdapat 3 section iaitu section AA, section BB dan juga akhir sekali section BB. Untuk mengira formwork itu, kami perlu melihat semula dalam section itu untuk mendapatkan jumlah yang diperlukan untuk membuat perimeter formwork tersebut dan juga ketebalan dia. Okey, seterusnya untuk DMP atau dikenali sebagai dam proof membrane, dia menggunakan thin polyethylene dam proof membrane iaitu ketebalan sebanyak 0.25 mm. Dan untuk hardcore kami menggunakan seperti broken stone, gravel dan lain-lain lagi yang telah diluluskan. Ketebalan hardcore ini sebanyak 150 mm. Untuk elemen seterusnya iaitu ground floor, terdapat 3 benda yang perlu diambil kira iaitu concrete, formwork dan juga reinforcement. Di dalam konkrit ini, kami dia seperti pengiraan untuk seperti slide tadi iaitu perimeter untuk formwork tersebut. Kami cuma mengambil jumlah area luar rumah yang bersambung ini. Sama juga seperti formwork, pengiraannya mungkin lebih kurang sama seperti pengiraan untuk rough foundation. Untuk reinforcement, kami telah menggunakan sejenis keluli yang dikenali sebagai mesh reinforcement kerana kami tidak menggunakan ground beam ataupun stump. Jadi dia diganti dengan rebar dengan mesh reinforcement ground floor. Okey, Itu sahaja daripada saya. Terima kasih.
Assalamualaikum, my name is Ainar Rimtukang Azman. My matrix number is 241-332-197. For my part in this mini project is in the snapshot that called about earthwork, which is site clearing, also and a little bit about concrete. And at the end of the video, I will show a little bit about bill of quantity, but in the site clearing. First, in the site clearing, which is 1.1, we have two data, which is for horizontal and vertical measurement, and both of that will multiply together, and we got 565.07 for the average total. This one is 1.2 excavation. For the hardcore, we have 100mm and plus with concrete slab, which is 200mm and got total 300mm. So to find the area excavation, we need to calculate with length, multiply by width, and multiply by the total we got for placing hardcore and concrete slab. So, and for the length we got for the excavation is 16764mm, and for the width 8229mm. So after that we got all the data applied, and in the end 275.9 and at 82.77 we plus together and we got 359 for the total in the excavation. And the last one in the site clearing is 1.3, which is disposal. Disposal have two types, which is organic material topsoil and subsoil material. Take back our value at the site clearing excavation, so we multiply together. Also we plusing it together, which is at 4.76 with 41.39, and also 82.77 we plus together and we got the end, and the end of the answer is 209. And the next I will talk about concrete, which is in ground floor also and rough foundation. First I will talk about 3.1 concrete in the ground floor. So first we need to find the slab, which is the area of slab that we need the value of leg, and will multiply with width. So the value, both of the value is the same as the excavation at first I showed. After we get the answer, we will multiply with thick, which is in the description show. Vibrate reinforced concrete grade 25 in ground floor, 200mm thick. So we change to the meter, and after that we get the final answer. And the final answer, both of that, which is 275.9 and 55.18, and the end of the answer will get the 331.08. As for the concrete in the rough foundation, which is 2.1, so in this case we just multiply together. For the concrete first, we need to find the slab first. After that we need to multiply it with the thick, but for this case we just multiply that together, so we get the final answer, which is 55.18.
Assalamualaikum. My name is Naisha binti Rezan. Today, I will present my part for the CCE subject, which is the reinforcement work for the rough foundation. A rough foundation is a type of foundation that spread the building load over a large area of soil. Because of that, reinforcement is needed to strengthen the concrete and improvement the stability of the foundation. Based on the slipshod form, the reinforcement used is mesh reinforcement in the rough foundation. The function of reinforcement is to resist tensile stress, reduce cracking, and increase the durability of the structure. Without reinforcement, concrete can easily crack because concrete is weak in tension. For this project, we use high tensile fabric reinforcement reference number A6. This type of reinforcement is commonly used in foundation because it provides good strength and is easier to install on site. To calculate the reinforcement quantity, we first calculate the mesh area using this formula. Area of mesh equal to length times width. The length of the rough foundations is 16.764 meters and the width is 8.229 meters. So the area is 16.764 times 8.229 equals to 137.35 meters square. After obtaining the area, we'll multiply it by the reinforcement weight, which is 2.22 kg per square meter. The calculation is 275.9 times 2.22 equal to 612.5 kg. Therefore, the total reinforcement required for this rough foundation is approximately 612.5 kilograms. Besides that, the mesh reinforcement is installed with lap joint. This means the reinforcement overlaps at the connection area to ensure continually and stronger bonding between the reinforcement bars. This method also helps distribute the burden load evenly throughout the rough foundation. During construction, it is important to ensure the reinforcement is placed correctly according to the drawing and specification. Proper spacing and positioning are necessary to maintain the strength and safety for the structure. In conclusion, reinforcement is an important element in rough foundation construction because it improves structure strength, reduces cracking, and helps the foundation safely support the building load. Another important point is that reinforcement must be properly tied and supported before concrete pouring begins. This is to make sure the reinforcement does not move during the concreting process. In reinforcement work, cover blocks are also used to maintain the correct concrete cover. The concrete cover protects the steel reinforcement from corrosion, moisture, and fire exposure. This helps increase the lifespan of the structure. Besides that, quality control is very important in reinforcement installation. The contractor must check the reinforcement size, spacing, overlapping, length, and position according to the construction drawing and specification before approval is given for concreting work. If reinforcement is installed incorrectly, it may affect the strength and stability of the foundation and could lead to structure failure in the future. Therefore, proper reinforcement installation is essential to ensure that rough foundation can safely transfer the burden load to the ground. Thank you.
Assalamualaikum. My name is Muhammad Adam Faris bin Muhammad Khairi. My matric number is 241332205. Today, I'm going to explain about a formwork. The drawing that we got is the rough foundation, which means that we need to calculate it meters square. We will start with the section AA. So the total perimeter is 4267 plus 1219 plus 2743 plus 2743 plus 1219 plus 4267. Then we will get the total perimeter is 16458. Then we must deduct with the specific depth, which means then we will get 13.308 meter. Time with the depth is 100 millimeter. We change it to meter, then we will get 0.1 meter. Then we must time with 2. Then we will get 2.662. So the length that we deduct just now, we must time with it specific depth, which the first one is 600 millimeter, 0.6 meter times with 0.425 meter, and then we must time with 4. Then we will get 1.02 meter square, and the other is 0.6 meter times 0.225 meter. Then we must time with 4. We will get 0.54 meter square, and the final one is 0.75 meter for its length, and then the depth is 0.225 meter. Then we must time with 2. Then we will got 0.338 meter square. So we must total up the answer we got just now. Then we will got 4.5956 meter square. So we will round off 4.56 to 5. Then we write the quantity at the top right. And for section BB, the total perimeter is 16.458. Then we must deduct it with the specific depth. Then we will get 11.658 meter. We must time with the depth 100 millimeter, change it to meter, then we will get 0.1 meter times 2. The answer we got 2.332 meter square. And for the other length is, we must time it with the specific depth. We will get 0.6 meter times 0.425 meter times 4. And the answer is 1.02 meter square. Okay, for the final one is 0.6 meter times 0.325 meter times 12. Then we will get 2.34 meter square. Then we must sum up the answer. We will get 5.692. So we will round off to 6. For last section, which is section CC, the total perimeter is 13.107 meter. Then we must deduct with the specific depth. We will get 10.107 meter times with the depth is 0.1 meter. Then we must time with 4. We will get 4.043 meter square. And for the other length, we must time it with the specific depth. The depth is 4 0.425 meter. Then we must time with the length 0.6 times with 8. Then we will get 2.04 meter square. And for the final part is 0.6 meter for its length. And then with the depth is 0.225 meter. Then we must time with 12. Then we will get 1.62. We sum up the answer we got, we will get 7.703 meter square. Then we will round off it to 8. That's all from me. Thank you very much.
In the last of my part, I will talk about bit of quantity, but just at the earthwork. So for 1.1 exact clearing, which is for the exact amount, we got 2,034.25 ringgit. So the amount we got from the quantity multiplied by rate. Same goes to the excavation, which is the amount we will get 1655.40, and also the disposal, and we got the end of the answer 6601.87.
Assalamualaikum. Nama saya Muhammad Amin bin Muhammad Syahri. Nombor matrik saya 2413334110. Saya akan introduce PQ. Let's start. Moving into the financial breakdown, our bill of quantity is categorized into 3 primary sections: earthwork, the rough foundation, and the ground floor construction. The total estimated cost for this element is divided into 2 collection stages. The first one is earthwork. First, let's look at earthwork, which total RM 10,291.52. This includes site clearing, covering an area of 565.07 m² at the rate of RM 3.60, totaling RM 2034.25. Second one is excavation. We have calculated at 2.77 m³ of excavation to reduce level, priced at RM 20 per unit, coming to RM 1655.40. Disposal. The largest portion of the section is the disposal of surplus material away from the site, totaling 208.92 m³ at a rate at RM 31.16, which equal to RM 6601.87. The third one is element, rough foundation. Next is the rough foundation. The total collection for this element is RM 37331.08. Key contributor include concrete, We are using 55.18 meter cube of grade 25 reinforced concrete, which at Rm491 per meter cube amount to Rm27093.38. Second one is mesh reinforcement, estimated estimated at 912.5 kg at the rate of Rm4.64 totaling Rm2842.00. The third one is dam proof membrane (DPM), a 0.25 mm polyethylene layer covering 612.5 meter square cost Rm3613.75. No, not the last one. For the hardcore is 115 millimeter thick layer over 275.9 meter square at Rm2841.77 to the budget. Formwork, sawn timber formwork for the site account for Rm940.15, and the subtotal for the earthwork and the rough foundation is Rm47,622.57 cents. Let's move to the next one. Finally, for the ground floor element, the total collection is Rm 535.38 ringgit. The breakdown is as follow. For the first one is concrete. Similar to the foundation, we require 55.18 meter cube of grade 25 concrete for the 20 millimeter thick floor, totaling Rm 27.063.38. The second one is for the reinforcement. Another 612.5 kg of mesh reinforcement is required at Rm 2842.00. Third one is formwork. Sound timber formwork for the ground floor site, not exceeding 215 height, is estimated at Rm 9600. In summary, the total cost for this work is the sum of our two collection page, providing a comprehensive budget for the substructure of this semi-detached unit. Thank you.